All right, today's lesson is on 12.4, multiply rational expressions. 12.4 we actually split into 2 days, so this will be day 1. We're going to work on multiplying rational expressions. Day 2 we'll be working on dividing rational expressions. So don't really have anything on this slide, but there's the title to go at the top of your notes. All right, so when we are multiplying rational expressions, if you can, you do want to factor everything first and then go ahead and do the multiplication or the simplifying, and I'll show you what that means. But if you have two rational expressions like these, we have a monomial over a monomial times a monomial over a monomial. If there's no addition or subtraction, you can't actually do any factoring. So in this case, what we're going to do is we will go ahead and just multiply straight across on the top and multiply straight across on the bottom so that we get one fraction, and then we'll go through simplifying our fraction. So this kind of takes us back to chapter 7 with our exponent properties. First, we'll multiply coefficients. -3 times nothing, which is a 1 basically, is -3. And then multiply the x's. X to the 6th times x squared. You will be adding your x's or your exponents, so you have x to the 8th power. And then the y squared doesn't have anything to multiply with, so that stays as a y squared. Over, now again start with your coefficients. You have a 7, so your 7 times 1 is 7, and then z to the 3rd times z to the 1st is z to the 4th. All right, so now what we want to look at is if we can do any simplifying of our answer. So go ahead and look at the coefficients, and -3 over 7. If that was its own fraction, could you reduce it? Because there's nothing that you can divide them both by, that's fine. And then you want to simplify the x's, the y's, and the z's. Well, this example is kind of nice because you can see that you have these x's on top, but you don't have any other x's to simplify it with. The y's, you don't have any other y's or any other z's. So this problem's actually done. We multiplied straight across, and then we looked at simplifying the coefficients and the variables, but turns out we couldn't simplify anything. All right, so here's another example. We're multiplying two rational functions, so we will start by multiplying straight across. Again, because there's no factoring that we can do, and you'll see how those problems work, we go straight across, multiply coefficients first. We have 3 times 2 gives us 6. M squared times m squared, add those exponents, you get m to the 6th power. Now you have an n cubed here, but you don't have an n cubed on the other side, so that's just going to stay as n cubed. And then we've got some p's we can multiply. P times p squared is p to the 3rd power. All over. Now when we multiply the denominator, you've got your 6 times 8. So we have 48. And then multiply the m's. Well, all you have is the m to the 4th over here, so that's just m to the 4th. The n's would be next. N times n squared is n cubed, and then that p to the 3rd stays the same. All right, so we're going to go through our answer one piece at a time to do our simplifying. First, if you notice, we have 6 over 48. We can reduce that. If you divide them both by 6, you end up with a 1 over 8. All right, next you have m to the 6th over m to the 4th. Well, anytime you're dividing the same base, if you remember, we keep our base the same and subtract the exponent. 6 minus 4 is 2. All right, now you've got n cubed over n cubed. Anytime that it's the same, they cancel each other out. P cubed over p cubed cancels. So our final answer is 1m cubed over 8, or not cubed, squared, or m squared over 8. And that one is done. All right, this actually would be the last example in the intro video, and then the second video has some really good examples for more problems like these. So we're asked to multiply the rational expressions, but it says always factor first if possible. So what I'm going to do is I'm going to rewrite this problem. I notice this one has some addition in it, which means maybe we'll be able to factor this. The first fraction, you have this a plus 3. Anytime it's two terms, you want to see if there's a GCF or if it's a difference of squares. This is not a difference of squares pattern, and there is no GCF to take out. So that's going to stay as a plus 3 over the 2 doesn't change, can't factor one term, times. Now the 6 will stay, but we want to take a look at the 3a plus 9. Two terms, look for a GCF first. Looks like we can take out a 3, and that's going to leave you with an a plus 3. And then just to double check, can you keep factoring the a plus 3? It's two terms, but it has addition, so it's not a difference of squares. So technically, here's what we're doing. When you multiply fractions, we do want to multiply straight across. So you have an a plus 3 times a 6 over a 2 times a 3 times an a plus 3. Now this step of rewriting it like this, in the second video you'll see how you can kind of shortcut through this, but I just in the explanation want to show what's happening. So you multiply two fractions, you basically multiply straight across. So I've shown that we've multiplied straight across, and I haven't actually multiplied anything yet, but I do have this set up as multiplication in between all these parentheses. So what you can do next is kind of fun. You're going to look for anything on the top that you can cancel with on the bottom. And do you see this a plus 3 is being divided by an a plus 3? That means that we get to cross those off. They cancel each other out. A plus 3 divided by a plus 3 actually equals 1, so those are gone. If you look at what you have left, you have a 6 on the top. On the bottom, you have 2 times 3. Well, 2 times 3 is 6. And now we're looking at 6 divided by 6. And what does 6 divided by 6 equal? Well, 6 divided by 6 is equal to a 1. And this 1 will be our final answer. So if there's any factoring to be done in these problems, if you have addition, or subtraction like this one, you want to factor everything first, and then you're looking for things to cancel out. And that's how we get a simplified answer. You notice we canceled out the a plus 3s, and then we looked to see kind of what we had left over. So the next video we'll go through some really nice examples doing that.